you'll take that function. We can model it in our, place it in our Y editor and take a look at its vertex, right? The optimal revenue is going to be the vertex of this equation. So if we enter this, and we can just put it in the form that it's in, so 200 plus 10x times 40 minus x. Okay, when we view the graph of this, okay, it doesn't fit on our viewing window, so we do have to zoom fit to make sure we can see at least a portion of the actual data. Okay, and in this one, it just gives us the left side of it. It's kind of hard to gauge whether this is exactly the vertex or not, so I'm going to widen my window a little bit. I'll increase this to 40 for my x maximum. The other things are fine. So when I go back to view my graph, I can now see where my vertex is. So I'm going to find the coordinates of that using the Math tab, F5. It's a maximum point. Make sure my lower bound is to the left and below that vertex. My upper bound is going to be to the right and below the vertex. And this is going to give me my solution. So my maximum point, or vertex, is going to be 9.99 repeating. So that rounds to 10 and 9,000. All right, so most of you got this. The optimal revenue is going to be 9,000. But how do you identify what the optimal price should be? Well, it said that the starting price was $200, right? And what this vertex, or the x-coordinate of the vertex, tells you is how many price increases there were going to be. So we know that there's going to be 10 price increases. And what's each price increase based on the problem? It says that for each $10 increase in price, one less system is sold. So this is saying there's 10 $10 increases. So what's 10 times 10? So we're adding 10 $10 increases, or 100, to it. And so we get an overall price of $300 is the optimal price. Does it make sense how that doesn't convert directly over? It's not just a 10, and it's not just adding 10, it's adding 10 times 10.